Good morning, students. In today's class, we are going to discuss about the intensity of electric field. That's what we discussed yesterday, previously a little bit topic. Thereafter, what is uniform and what is non-uniform electric field intensity and the intensity of electric field due to isolated point charge. This is a small derivation and these are the theory parts. Okay. So, what is the intensity of electric field? Intensity of electric field F is equals to what we know yesterday's class. F is directly proportional to Q and F is equals to EQ. F is equals to EQ and implies that means we are going to change this formation subject of the formula. We are going to change the subject of the formula. F we are going to change. Here F is the subject of the formula. Now I am going to change in this E as a subject of the formula. That's why I will write first E. E is equals to F by Q. F by Q. Since force is a vector physical quantity and product of one vector and a scalar, again it is a vector. Okay. It is a vector. Product of vector and scalar is again a vector. Here E bar is equals to F bar by Q. This is electric field intensity representation. Look, what is the unit of this one? It is E bar. Its unit is Newton per Coulomb. Newton per Coulomb. It has certain direction. I told yesterday, what is the direction of this one? Suppose you are having a charge Q and you are having a positive charge here. Positive test charge and here it is a positive charge. In the field of this one, this is located. Definitely, both are positive charges. Definitely, you will have repulsive force and it is directed away from the charge, away from the field. This is the field. Okay. Direction of electric field is this one. How you are concluding this one? Why it is? Because these two are positive charges. These two are get repelled. The direction in which it is repelled is the direction of force, which is the repulsive force, is the direction of electric field also. ఏ డైరెక్షన్లో అయితే రెండింటి మధ్య రిపల్సివ్ ఫోర్స్ పనిచేస్తుందో అదే డైరెక్షన్లో ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఉంటుంది. సో దిస్ ఈస్ ద డైరెక్షన్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ. Suppose this is a negative charge. Okay, then it is a test charge is always positive charge. Okay, then what happens? The force of attraction between these two is acting towards the charge. In this direction it is acting. Okay, this is not present. I hope you understand this one. Okay, so this is the direction of attractive force. In the same direction, electric field intensity also present. Electric field intensity, the direction of electric field intensity is the direction of force. Here it is attractive force. In previous case, it is a repulsive force. Okay, this is how we can conclude the direction of electric field. If it comes, then I will explain. So note these points, this diagram and previous diagrams, and now come on to the uniform and a non-uniform electric field intensity. Uniform, suppose అంటే మీకు డౌట్ రానిది నేను చెప్పిన అర్థం కాదు. మీకు డౌట్ వస్తే మెసేజ్ పెట్టండి, డెఫినెట్గా నేను చెప్తాను. ఆ సపోజ్ దగ్గర ఏంటంటే మీరు ఫిల్ చేయండి. చదివిస్ మీకు ఏ ఐడియా వస్తే ఆ ఐడియా పెట్టండి. Right or wrong, I will give you suggestion. Okay, so uniform and non-uniform electric field intensity or electric field strength. Let me explain what is uniform. Suppose these field lines, electric field lines are located like this. When you will get like this, yesterday I have given this. When you are having long charged body, then you will get the uniform electric field between positive charged and negatively charged conductor. You will get a uniform electric field. Uniform electric field. Okay, how can I say this is uniform? If I brought a positive test charge, if I brought a positive test charge, if I brought a positive test charge and placed it here Q naught, then it will experience a force. From this side, it will experience a repulsive force. Okay, and from that side, that will experience a attractive force. Now I will try to erase this one because this will present at longer distance. Otherwise, you will get confused. It is located here. The first situation. In second situation, it is located here. And in third situation, it is located here. There are three situations. There are three situations, 1, 2, 3. In all the three situations, the force experienced by this given positive test charge is equals, the force experienced by the positive test charge is equals, and this is equals to electric field intensity. If it happens, if it happens, then the given field is said to be uniform electric field. What is the formula for electric field? E bar is equal to F bar by Q naught, where Q naught is a positive test charge. So electric field intensity is uniform when a positively test charge is located in the field wherever it is, it will experience a same force. It will experience same force per unit charge. Then we are calling this is equals to electric field intensity or electric field strength. But dear children, you are just learners. If you not understand means, you try to listen once again and once again. Okay. After drawing this picture, pause the video and drawing. After drawing this picture, you can once again listen. Now, I have a charge here, positive charge. And you all know that how the field is spread. Field lines are moving away from the positive charge. That is the symbol. How can you identify the charge? If the field lines are moving away from the charge, this is a positive charge and this is the electric field, direction of the electric field, and we are calling this total location where the field lines are spread over here is called electric field. Observe this one. Suppose if I place a positive test charge here, this is the first location and here it is the second location and here it is the third location. So these three test charges, what is the test charge? A unit positive charge is always a test charge. Since it is a positive, these three locations, in these three locations it will experience a repulsive force. When it is affected by the repulsive force, the force will move away from the positive charge. So this is direction of electric field intensity. That's what we discussed in previous slide. Okay. So here these test charges Q naught is located in three locations. What is the force experienced by this one? Force experienced by this first positive test charge is EF bar divided by Q naught. Force experienced by test charge, and F bar by Q naught and F bar by Q naught. All the three are positive test charge. There is no change in test charge, but there is a change in force experience. There is a change in experience of force. That is not constant. Because when it is located here, observe these field lines. They all are. It is affected by three field lines. Here there is no chance. Not at all. But it is somewhat near to this this line and this line, this may experience a little bit more less force, because when they are very near to this one, chudandi, when these two are very near to this one, like this, observe here, from Q naught, these two are located very near, here and here. But from Q naught, these two are located somewhat far distance than in previous case. But here, they are not at all near to this Q naught. So it will experience more force, it will experience less force, it will experience no force. So F1, F2 and F3. If you name this one as F1, F2 and F3, they are not same. So they are experience a different force when it is very near to that somewhat far distance and far distance. This will experience a different force. So your electric field intensity is a different. Electric field intensity is a different at a different locations. Different at a different locations. This is a E1 and this is a E2 and this is E3. Once I written E1 and E2, E3 names are different, then strength of the field is also different. If I written E, that means same electric field strength. If I written E1, E2, E3, it itself give you idea that they are not same. They are not the same. So E1 is not equal to E2 is not equal to E3. E1 is not equal to E2 is not equal to E3. If the field is like this, I mean the force experienced with test charge is different at different locations. Okay, then the field is said to be non-uniform electric field. Then the field is said to be non-uniform electric field. I hope you got this one. Nana, ಈ derivation avadu it will take once again 10 to 15 minutes. That's why I am going to end this class, today's class here. Still some of you are not at all going through this one. And observe how I am teaching here. Very slow, in very slow manner I am going, because every student from all the sections, I mean star A, star B, IIT sections, F1, F2 and F3 are regular sections, all must listen this class. That's why I am going very much slow and prepare notes. And still you are having any doubt means, please send me message, then I will clear that. So today only two topics were completed: intensity of electric field and uniform and non-uniform electric field. Draw these fields and try to explain yourself by using these equations. Okay. So thank you very much.